Okay, welcome you guys. Myself Sathyamoorthy, verified plus educator in the Unacademy platform. Today, it's a discussion about it's a class about the discussion on Euler-Cauchy equation. So Euler-Cauchy equation is higher order differential equation. Higher order differential equation. This is the concept. Today we are going to discuss about the Euler-Cauchy equation. This Euler-Cauchy equation same as our linear higher order differential equations with constant coefficients. Only thing here variable coefficient. Okay. So Euler-Cauchy equations in the subject of Euler-Cauchy equations from the differential equation in the subject of engineering mathematics for the GATE 2020 mechanical engineering examination. Now, as per our discussions in the previous discussion, the complementary functions the same as our ordinary differential equation, with constant coefficients. Roots of the equations and roots are real and different. M1 and M2 are real value but different. This is a complementary function. Already I have discussed these things in the previous class itself. The discussion on higher order differential equations part 1 to part 5. These contents already discussed in those things. Here roots are real and equal. M1 is equal to M2 is equal to M. When roots are real, this is a complementary function. When roots are imaginary, alpha plus or minus beta a is equal to complementary function e power alpha x into a into cos beta x plus b into sin beta x. So this is the format. Now, these are the particular integrals. As per the particular integrals, now these are the different cases. We have discussed these things in the higher order differential equations with constant coefficients itself. These are the constant coefficients. Based on these 8 cases, we are going to discuss the Euler-Cauchy equation. Coming to the Euler-Cauchy equation, it is the Euler-Cauchy equation here. Euler-Cauchy equation, linear differential equations with variable coefficients. What is meant by variable coefficients? Why we are moving into the Euler-Cauchy equation? It's a normal ordinary function belongs to the constant coefficients. Euler-Cauchy equation used to determine the solution to the differential equation with variable coefficient. The variable coefficient and equation of the form x power n into d power n into y divided by dx power n plus a1 into x power n minus 1 into d power n minus 1 into y divided by dx power n minus 1 plus a2 into x power n minus 2 into d power n minus 2 into y divided by dx power n minus 2 plus here up to the n value. Here the function depends upon the variable or parameter s, where a2, a3 up to the n are constants and f of x is a function of x. So here the difference in between the constant coefficient and variable coefficients. In front of the differential operator we are having x. It's a variable. X is a variable. So in the previous case we had a discussion about the constant coefficient. Here it's a variable coefficients. The above equation can be ready. Usually we can derive the solution to the differential equation only in the category of constant coefficient. So here the differential equations with variable coefficients are converted into the constant coefficients. The above equation, this equation can be reduced to linear differential equation with constant coefficients. Linear differential equation with constant coefficients. By putting the substitution, x is equal to e power n, e power z. Then z is equal to log x. So these are the substitution. Instead of x, we are substituting e power z. Instead of log x, we are substituting z. When we make this substitution, the equation with the variable coefficient will be converted into the constant coefficient. Then we can proceed as per the constant coefficient differential equation. Yes, it's a chain rule. How we are making the substitutions? We know that chain rule. dy divided by dx can be written it as dy divided by dz into dz divided by dx. So when you are cancelling dz and dz, again the same value, it is dy divided by dx format. Now take this value when you are differentiating the given equation, okay, with respect to the x, the z term when you are differentiating 1 divided by x, 1 divided by x into dy divided by dz. So directly dy divided by dx is equal to, yes, dy divided by dx is equal to 1 divided by x into dy divided by dz. Okay. Yes. Now dy divided by dx is equal to 1 divided by x. Take this x into the LHS side. Take the x into the LHS side. So into the numerator, from the denominator into the numerator. So x into dy divided by dx is equal to dy divided by dz. Dy divided by dz. Now substitute theta is equal to d divided by dz. Right? Because as per our differential equation discussion, we did a substitution in the differential equation, that is capital D is equal to d divided by dx. In the Euler-Cauchy equation, we are making the substitution, that is equal to instead of d divided by dz, substitute theta. So in this equation, okay, converted into theta into y. Instead of dy divided by dz, it is theta into y. So this is the substitution. So coming to the next substitution, see these are the substitution here. These two substitution belongs to the LHS side. These two substitutions belongs to the LHS of the given differential equation. It is LHS. Yes, it is LHS side. Now these two substitutions belongs to the RHS of the given differential equation. RHS of the given differential equation. Now in the LHS side, this is a substitution we are going to do in the differential equation. X into dy divided by dx is equal to, okay, already we have discussed this thing, is x into dy divided by dx is equal to theta into y. So coming to the next one, when you are increasing the polynomial order for the variable coefficient, x square into d square y divided by dx square is equal to theta square minus theta into y. Theta square minus theta into y. So this is the value here. Now RHS side, instead of x, we are substituting e power z. Instead of log x, we are substituting z. So these are the substitutions. As per the substitutions, we are going to discuss the problems. So coming to the first problem, here x square into d square minus x into d plus 1 into y is equal to log x divided by x the whole square. Okay, we know that we have to make the substitution, that instead of, we know that x square into d square is equal to x square into d square y by dx square. D square y divided by dx square is equal to the capital D square. Okay, as per the discussion, the substitution, we know that the instead of x, we have to substitute e power z. Instead of log x, we are substituting z. Now the LHS side, x square into d square y divided by dx square is equal to theta square minus theta into y, and x into dy divided by dx, is equal to theta into y. So these are the substitution we are making here. Now substitute, instead of x square into d square is equal to theta square minus y. Sorry, theta square minus theta. This is equal to theta square minus theta, minus, instead of x into y, substitute again theta, again minus theta. Here plus 1 into y is equal to, here log x is equal to z, then x is equal to e power z. So these are the substitution. Now square this term z square, then e power 2z. So the e power 2z taken into the numerator. So minus 2 power minus, okay, e power minus 2z. So as per the discussion, now compare this value with the differential equation that is in the form of x power n into e power ax format. So instead of x, we are using here z in the power. So as per this format, so we have to multiply this value e power x e power x into x power n format. As per this format, we have to decide. Then e power ax into x power n format. We know the formula for the equations. Yes, as per the discussions in the higher order linear differential equations with constant coefficients. Here, e power ax into pi of x. Pi of x, it may be x power n or psi of sin ax or cos ax. Now, in the x power n, we have to take this e power ax front side. Then in the denominator, instead of d, we are substituting a. As per the same discussion, we have to substitute instead of the denominator theta, we have to substitute the a, constant a value. Yes, here. The solution, first we need to identify the LHS side. LHS side, the solution to the LHS is the complementary function. Coming to the complementary function theta square minus 2 theta plus 1 is equal to 0. Plus 1 is equal to 0. The auxiliary equation for the auxiliary equation is given as, we are replacing the theta by m. So theta square is equal to m square minus 2 theta is equal to 2m plus 1 is equal to 0. The m square minus 2m plus 1 is equal to 0. Now m minus 1 into m minus 1. Okay, these are the root values. M is equal to 1, m2 is equal to 1. So these are the root value. We can use the shortcut method. That is, when you are multiplying this root value minus 1 and minus 1, it should give plus 1. When you are adding the root value, it should give minus 2. So this is the shortcut. As per the shortcut, m minus 1 into m minus 1 is the root values. So we can use another formula, minus b plus or minus b square. You know that m is equal to, one more formula, the actual formula, minus b plus or minus root of b square minus 4ac. Minus 4ac divided by 2a. So this is the condition. Now minus b is equal to minus of minus 2 is plus 2 divided by root of 4 minus 4ac. The 4ac is equal to again 4 divided by 2. Now 2 plus or minus 0 divided by 2. Now it is equal to 1 plus 0, second one 1 minus 0. So there are m1 and then m2. m1 and m2 are equal to 1. When the root values are equal, then we have to substitute the value. When roots are equal, this is the format as per the ax plus b into e power ax. Okay, instead of x, we are using the z here in the equation, complementary solution as well as particular integral. So az plus b into e power z. We know that the substitution what we did in the previous case at the start of the equation. These are the substitution. Instead of x, we have substituted e power z. Instead of log x, we have substituted z. Again in the final solution, the complementary function, again we have to reverse the process. Instead of log x, we are going to substitute z. Okay, so instead of z, we are going to substitute log x. Instead of e power z, we are substituting x. So coming to the equation, now z equal to log x, e power z is equal to x. So complementary function is equal to a into log x plus b into x. Next we are moving into the particular integral. The particular integral for the given equation. it is right hand side, z square into e power minus 2z, z square into e power minus 2z. So coming to the equation, particular integral pi is equal to 1 divided by theta square minus 2 theta plus 1 into z square into e power minus 2z. As per our discussion, we have to take this e power 2z front side, then in the denominator when you are taking this e power minus 2z and then front side, we have to replace the theta by theta minus 2, theta minus 2. So here e power minus 2, so instead of theta we are replacing that theta minus 2. Now substitute theta minus 2 the whole square minus, instead of theta substitute theta minus 2 again plus 1. Now simplify the denominator, here a minus b the whole square format, theta square plus 2 square is equal to 4 minus 2 into 2ab, that is 2 into theta into 2 is equal to minus 4 theta minus 2 theta plus minus 2 into plus minus 2, it's a plus 4 plus 1. Now theta square minus 6 theta plus 9 into z square, so this is the denominator. Now here thing is, we have to convert the denominator. When you are getting the x power n formula, it is equal to the e power z is equal to the x power n category. It is equal to the x power n, x power n category. As per the x power n, in the denominator we have to convert it into the 1 plus r, 1 plus x or 1 minus x. Yes, this is the thing. We have to expand the denominator, that is f of d. So previous case differential equation, as per our Euler-Cauchy equation, in the denominator f of theta, f of theta. So here in the denominator we have to take this f of theta into the numerator. So when you are taking this value into the numerator, you are getting the binomial expansion format. That is 1 plus theta, 1 plus x or 1 minus x format in the denominator. Then we are taking this into the numerator. Yes, the denominator is converted into 1 plus x format. Here theta square minus 6 theta plus 9. Okay, 1 plus x format, take the 9 outside commonly. So 9 into 1 plus the whole time theta square minus 6 theta divided by 9 considered as x. So 1 plus x category. This equation is equal to the this equation is equal to the 1 plus x, 1 plus x category. So when you are taking this 1 divided by x, 1 plus x is equal to 1 plus x whole power minus 1, whole power minus 1. Here the thing is taken into the numerator, the total term 1 plus x taken into the numerator. So e power minus 2z divided by 9 into 1 plus theta square minus 6 theta divided by 9 whole power minus 1 into z square. Then as per the 1 plus x binomial formula, we have to expand it. We have to expand it. Then, okay, then up to which we have to extend this. As per the z square, we are expanding. Theta square maximum value is equal to, sorry, theta power is maximum value is equal to 2. The z power value, here we are keeping it as maximum value theta square. The more than the theta square, theta cube, theta power 4, theta power 5 are eliminated, because when you are differentiating one time. So coming to the equation, when you are differentiating the z one time with respect to the z square, it is 2z. The second time theta square of z square, theta square of z square is equal to 2. Third time onwards it is 0. Third time onwards it is 0. So we are eliminating the theta power more than 2. The 3, 4, 5, 6 are eliminated. So we are stopping the exponential binomial expansion formula up to the theta square. Now the 1 plus x whole power minus 1 is given it as This is a formula, binomial expansion formula. 1 plus x whole power minus 1 is equal to 1 minus x plus x square minus x cube plus x power 4. Okay, as per the discussion, these are the shortcut method used to remember the formula. Here plus minus, two different signs. So here plus minus plus minus. Alternatively, we are giving the sign. Then in the second formula, 1 minus x whole power minus 1. It is equal to 1 plus x plus x square plus x cube plus x power 4. Okay, vice versa, we are increasing. As per this equation, coming to this equation, 1 plus x whole power minus 1 is equal to 1 minus x plus x square minus x cube plus x power 4. Okay, etc. 1 minus x. Okay, here 1 plus x whole power minus 1 formula we are using. Yes. As per the discussion, expand it up to the square. Okay, when you are giving cube, so theta power comes into that cube. So we are eliminating the theta power 3 on it because we are stopping the theta square itself, and the theta cube, when you are multiplying the z square with the theta cube, 3 time differentiation of z square, it is 0. So we are eliminating the theta cube on which, so 1 minus x plus x square. This is a formula. This is a formula, that is 1 plus x whole power minus 1 is equal to 1 minus x plus x square minus x cube plus x power 4 minus, okay, so up to the n we are expanding. So we are stopping this expansion. We are stopping this expansion up to the x square. Now coming to the square, 1 minus x, 1 minus theta square divided by 9. Here minus of minus plus, so plus 6 theta divided by 9. Now expand this formula as per the a minus b whole square. So theta square minus 6 theta the whole square, that is theta power 4 divided by 9 square plus b square 36 theta square divided by 9 square minus 2ab, 2 into theta square into 6 theta, that is minus 12 theta cube divided by 9 square. The higher order terms, the theta power more than 2 are eliminated. So theta power 4, theta power 3 are eliminated here. Now coming to the equation, we have to multiply the z inside. We are multiplying the z inside. 1 into z square, then theta square into z is equal to 2. So 2 divided by 9 plus theta into z square, that is one time differentiation of the z square, it is 2z. So 2z into 6 is equal to 12z divided by 9 plus theta square is equal to 2 into 36, 72 divided by 81. Now cancel that 72 divided by 81, that is 8 divided by 9. Now take the LCM as per this equation. It's 9 taken it as LCM. So 9 is the LCM for this equation. So 9 z square divided by 9 plus 12 yes. Here 12, you are taking the LCM, we have to multiply the 9 denominator as well as numerator. Here we have multiplied, so e power minus 2z divided by 9 into 9z square plus 9 plus 12z. Simplify these two equations, what we are getting, 8 minus 2, it is plus 6 divided by 9 plus 6 divided by 9. Now the 3 is taken into the outside. The 3 we are keeping this 3 outside. When you are keeping this 3 outside, so 3 9, so 3, then cancel, remaining 3 12, 3, okay, 12 divided by 3 is equal to 4, 6 divided by 3 is equal to 2. So this is the equation. Now what we are doing, we have to replace the e power z as per our discussion in the previous slide. Here already we made a substitution, x is equal to e power z and log x is equal to x. In the final particular integral, again we have to reverse the substitution. Instead of z we are substituting log x, instead of e power z we are substituting x. Yes, now substitute e power z equal to x. So x power e power minus 2z is equal to x power minus 2 divided by 27 into z is replaced by log x. So z square is equal to log x the whole square plus 4 log x plus 2. Now x power minus 2 is equal to 1 divided by x square. X power minus 2 is equal to 1 divided by x square. So 1 divided by 27 x square into 3 log x the whole square plus 4 log x plus 2. So this is the particular integral. The total solution for the given differential equation is the addition of complementary function plus particular integral. Okay, this is the equation. As per the discussion, we are going to discuss the few more questions relating the Euler-Cauchy equation. Okay. Yes, the next problem is here. The first problem regarding the Euler-Cauchy equation, the particular integral of d square y divided by dx square plus 1 divided by x into dy divided by dx is equal to 12 log x divided by x square. So what is the particular integral? Here the 1 divided by x indicates that it's a variable coefficient. So we have to use the Euler-Cauchy equation as per the Euler-Cauchy equation. Now coming to the Euler-Cauchy equation, okay, we will derive it. First thing, take this x square into the left side. Okay, left side. So x square into d square y divided by dx square plus x square into 1 divided by x is equal to x into dy divided by dx is equal to 12 into log x. 12 into log x. What are the substitution we are going to make in the equation? We know that the substitution put, that is in first left hand side, x square into d square y divided by, as per the Euler-Cauchy equation. Okay, wait a minute. Yes, here make the substitution, that is put x square into d square y divided by dx square is equal to theta square minus theta into y. The one more substitution, that is equal to x into dy divided by dx is equal to theta into y. So this is the substitution. Next, x is equal to e power z, then log x is equal to z. So these are the substitution we are going to make. These two, first two, x square into d square y divided by dx square is belongs to the LHS of the given differential equation, and x into dy divided by dx is equal to the theta y, is equal to the theta y. So here theta square minus theta into y minus, plus theta into y is equal to 12z, is equal to the 12z. Now take this y outside, so theta square minus theta plus theta into y is equal to 12z, is equal to 12z. Now theta plus theta minus theta cancel, theta square into y is equal to 12z. The particular integral, we know that the particular integral is given it as pa is equal to 1 divided by f of theta into x power n. Here z power n. So is equal to 1 divided by f of theta is equal to the final equation. This equation is called as theta square into y is called as f of theta. Now it is equal to the theta square. So 1 divided by theta square into 12 into z. So this is the formula. Now 1 divided by theta square indicates that we have to integrate the z 2 times with respect to the z. The first time integration 1 divided by theta is equal to 12 into z square divided by 2. Again the second time integration is given it as 12 into z cube divided by 6. So that is equal to 2 into z cube. We know the substitution. What we are doing here as per the substitution here. Coming to the substitution, the previous thing. We had a substitution, that is x is equal to e power z equal to log x. So instead of log x, so z substitute log x. So coming to the substitution, here is equal to 2 into log of x whole power 3. So this is the solution. 2 into log x whole power 3. So 2 into log x whole power 3. So option D is the correct answer. For the given question. Okay. Now we are moving into the next question. Yes. This is the next question. The complementary function of x square d square plus 4xd plus 2 into y is equal to x into log x. Now as per the discussion, again we know that x square into d square, written it as d square y divided by dx square plus 4 into x into d is given it as dy divided by dx plus 2 into y is equal to x into log x. Okay, we need to make the substitutions. The substitution, put x square into d square y divided by dx square is equal to theta square minus theta into y. Then x into dy divided by dx is replaced by theta into y. Now one more thing, x is equal to e power z, and log x is equal to z. So these are the substitution. The first two belongs to the LHS side. The remaining two, x is equal to e power z and log x is equal to z, belongs to the RHS side. Now as per the substitution, what we are getting here, theta square minus theta into y plus 4 theta y, then plus 2y is equal to, instead of x we are substituting e power z, then log x is equal to z, e power z into z is equal to e power z into z. Now theta square minus theta plus 4 theta plus 2 into y is equal to e power z into z. Now theta square plus 3 theta plus 2 into y is equal to e power z into z. Now the particular integral is given it as pi is equal to 1 divided by theta square plus 3 theta plus 2 into e power z into z. Now take this e power z front side, then we are substituting theta is equal to theta plus 1. So theta plus 1 the whole square plus 3 into theta plus 1 plus 2 into z. So this is the substitution here. As per this substitution, again, now expand this formula. Expand this formula as per the discussion is equal to e power z into 1 divided by theta square is equal theta plus 1 square, theta square plus 1 plus 2 theta plus 2 theta plus 3 theta plus 3 plus 2 into z is equal to e power z into 1 divided by theta square plus 5 theta plus 6 into z. Now the z format, that is z power n format, so we have to change it to the denominator into 1 plus x format. Denominator into the 1 plus x format. So converting the denominator into the 1 plus x format, what we are getting? Just wait a minute. Yes, now we have to make the substitution as per the format. Now is equal to e power z 1 divided by, take the 6 outside, so 1 plus theta square plus 5 theta divided by 6, 5 theta divided by 6, okay, into z. Now take this numerator into the denominator into the numerator, that is e power z into 1 plus e power z divided by 6 into 1 plus theta square plus 5 theta plus 5 theta divided by 6 the whole power minus 1 into z. We know the expansion as per the previous problem discussion. So this divided by 6, 1 minus x, that 1 minus x is equal to theta square plus 5 theta divided by 6. So 1 minus x into z. So coming to the solution now. Yes. Is equal to e power z divided by 6, e power z divided by 6 into 1 minus theta square divided by 6 minus 5 theta divided by 6 into z. The higher order term eliminated. The remaining thing is e power z divided by 6. Multiply the z inside. So z minus, we are multiplying the z with theta. It is 1. One time differentiation of z. Theta means one time differentiation of z. That is 1. So plus 5 divided by 6. Plus 5 divided by 6. Now make the substitutions as per the method. Make the substitutions as per the method. Coming to the substitution. So here x divided by 6 into log x plus 5 divided by 6. So this is a particular integral. Here particular integral. Okay, the particular integral was not asked in the question. Okay, anyway, if we need to find the particular integral for the given question, this is the solution. Now coming to the complementary function. Coming to the complementary function. It's a complementary function solution. Coming to the complementary, we know that x square, that is theta square, that is theta square minus theta plus 4 theta plus 2 into y is equal to x into log x, x into log x. Okay, keep it as now theta square minus plus 3 theta plus 2. Take it as this equation is equal to 0 for the complementary solution. The auxiliary equation is m square. We have to replace the letter theta by m. So plus 3m plus 2 is equal to 0. The root values are, when you are multiplying the root value, you should give plus 2. So m plus 1 into, okay, it's a value m plus 1 plus into m plus 2 is equal to 0. The root values are m is equal to m1 is equal to minus 1, then m2 is equal to minus 2. Okay, we can take it as, okay, likewise. Otherwise, we can keep this value as per the ascending order. M1 is equal to minus 2, M1 is equal to minus 2, M2 is equal to minus 1. Now, the solution, complementary function, we know that complementary function is equal to a into e power minus 2z plus b into e power minus z. The substitutions are, we know that as per the previous problem discussion, these are the substitution. We are substituting that x is equal to e power z, x is equal to e power z. And instead of e power z, we are making the substitution x power z. Now substitute that e power z equal to x. So a into x power minus 2, x power minus 2 plus b into x power minus 1. X power minus 2 is equal to 1 divided by x square. So a divided by x square plus b divided by x, b divided by x. So solution for the given equation. But already I have derived the particular integral also for the same equation. If they are asking the particular integral for the same equation, as per the previous discussion, we have to identify the particular integral. Here the options are belongs to the complementary function. Now a divided by x square plus b divided by x. Option C is the correct answer for the given question. Okay. Now we are moving to the next question. Yes. Particular integral of x square into d square plus 4xd plus 2 into y is equal to x into log x. The same category. We have already in the previous case. The same category. Okay. Here I am giving it as same category particular integral. Okay. Already we have discussed these things. Same category in the previous slide. That was P is equal to. Already we had a discussion about this thing. Particular integral is equal to e power z finally. Okay, e power z divided by 6 into z minus 5 divided by 6. 5 divided by 6. This is a solution we got as per the particular integral in the previous problem. Okay, first I have derived the particular integral, then I have completed the complementary function. As per the first discussion, it is e power z. Instead of e power z, now take it as e power z divided by, take the LCM, 6 outside, take the 6 outside, so 6z minus 5, minus 5. Now coming to the equation, e power z, we are making the substitution e power z equal to x. So x divided by 36 into, instead of z, substitute the log x. So log x minus 5, minus 5. This is a solution as per this given options. Option A is the solution to the given equation. The particular integral of x square into d square plus 4x3 plus 2 into y is equal to x into log x. It's a solution. Option A is the correct answer for the given question. Next we are moving into the next question. The next question regarding the particular integral and total. Yes. Particular integral of x square into d square. Here the next problem belongs to the particular integral of x square into d square minus x3 plus 1 into y is equal to sine into log x is, sine into log x is a. 1 divided by 2 into sin log x, B 1 divided by 2 into cos log x, C 2 into sin log x, D 2 into log 2x. Coming to the explanation, first we need to substitute the difference as per our Euler-Cauchy equation. We are making the substitution x square into d square y divided by dx square. We know that d square is equal to d square y divided by dx square plus minus x into dy divided by dx, dy divided by dx plus y is equal to sin log x, sin log x. We know the substitutions for the Euler-Cauchy equation is, put the substitution, that is x square into d square y divided by dx square. Dx square is equal to theta square minus theta into y. Theta square minus theta into y. So this is the condition. Now x is equal to x into dy divided by dx is equal to theta into y. This is the substitution. Now x is equal to e power z, then log x is equal to z. Then make these substitutions in the given equation. What we are getting as per the substitution. Now x square is equal to x theta square minus theta minus theta. Here x square minus theta again plus 1 into y is equal to sin z. Instead of log x, substitute z instead of. Okay, now theta square minus 2 theta plus 1 is equal to sin z, So this is the equation. Now we are going to make the substitutions as per our discussion. The particular integral is equal to pi is equal to, we know that the particular integral of the given equation is equal to 1 divided by f of theta into sin az format, that is equal to 1 divided by theta square plus 2 theta plus 1 into sin z is equal to the sin z. Now is equal to, we have to replace the theta square by, as per our discussion, theta square by minus of 1 square, so 1 divided by minus of 1 square plus 2 theta plus 1 into sin z is equal to minus 1 plus 1 cancel, so 1 divided by 2 theta into sin z. So one time integration of sin with respect to the z. We are integrating the sin z, we are getting minus cos. So 1 divided by 2 into minus cos z. So that is equal to minus 1 divided by 2 into cos log x. Now coming to the options. Yes, when you are integrating, sin is equal to cos minus 2 theta, here minus 2 theta, so here minus 2 theta, so minus 2 theta, here also minus 2 theta. So coming to the minus 2 theta category, it's minus theta square minus 2 theta plus 1. Now it's here minus of minus, it is plus. So the answer is 1 divided by 2 into cos of log x is the answer for the given question. The cos 1 divided by 2 into cos log x is the answer for the given question. Okay, next we are moving into the next problem as per the Euler-Cauchy equation. Coming to the next equation. Yes, this is the next one. Now particular integral of x square into d square y divided by dx square minus x into dy divided by dx plus y is equal to, okay, what is the answer here? So we have to make the substitutions as per our discussion. Now make the substitution. Put x square into d square y divided by dx square, x square into d square y divided by dx square is equal to theta square minus theta into y, theta square minus theta into y. Then x into dy is equal to x into dy divided by dx is equal to theta into y. Then log x is equal to, then x is equal to e power z and log x is equal to z. So these are the substitutions as per the Euler-Cauchy equation. Now substitute this into the above equation. Now when you are substituting this equation, theta square minus theta into y minus theta y plus y is equal to, instead of log x, substitute z. So z plus pi, z plus pi. Okay, now theta square minus theta plus 1 into y is equal to z plus pi. That equation is equal to theta square minus 2 theta plus 1 into y is equal to z plus pi. Here z plus pi is belongs to the x power n category, as per our discussion. It is the x power n category. Is equal to the x power n. Particular integral is equal to x power n. Instead of x power n, we are having the z power n. So 1 divided by f of theta into z power n category. So here in the denominator we have to convert it into the binomial expansion format, that is 1 plus x format. Then we have to take this f of d into the numerator. Now taking f of d into the numerator, the answer is, taking f of d into the numerator, answer is 1 plus x or 1 minus x whole power minus 1. As per this formula, okay, coming to the problem. Yes. Now particular integral is equal to pi is equal to 1 divided by f of theta into z power n. Here f of theta is equal to 1 divided by theta square minus 2 theta plus 1 into z plus pi. So we have to expand it as per the binomial equation format, 1 plus x format. Already it was in the 1 plus x format, that is equal to 1 divided by 1 plus theta square minus 2 theta square minus 2 theta format, that is 1 plus x. It is equal to the z plus pi. This denominator is equal to, this format is equal to 1 plus x category. Now take this 1 plus x into the numerator. When you are taking this value into the numerator, that is equal to 1 plus theta square minus 2 theta whole power minus 1 into z plus pi. Now we have to expand it, okay, up to the term z power term, up to the z power we are expanding. Here z power is equal to 1. we are differentiating the z power 1 time d of z is equal to 1. So d square, second time differentiation of z is equal to 0. So the second time onwards we are taking it as 0. The 3, 4, 5 times are 0. So 1 plus x, given it as the binomial expansion formula. The 1 plus x is given it as the 1 plus x formula is equal to 1 plus x whole power minus 1 is equal to 1 minus x plus x square minus x cube plus x power 4 minus vice versa. As per this discussion, now expand it. When you are expanding it, is equal to 1 minus x, that is theta square minus 2 theta, okay, plus theta square minus 2 theta the whole square, okay, vice versa, into z plus x, z plus pi, z plus pi. The higher order terms are eliminated. So only thing 1 minus theta square. From this equation, what we are getting here, determine as this format. Now the expansion of this equation is equal to uh, 1 minus theta square plus 2 theta into z plus pi, the higher order term eliminated, again theta square, the thing is multiply the z plus pi inside. So z plus pi is equal to z plus pi, again multiply this z plus pi into the theta. We are differentiating the one time with respect to the z differentiation 1. So plus 2, again pi differentiation 0. The final answer is z plus pi plus 2. We know that the substitution is the z is equal to, as per the substitution, z is equal to log x. Z is equal to log x. Now substitute the z equal to log x in the final solution. So log x plus pi plus 2. So this is the answer, final answer for the given differential equation. It's a particular integral. So coming to the solution, option C is the correct answer. Option C is the correct answer as per our discussions. Okay. So these are the things. We got a very good discussion about the Euler-Cauchy equation. The same type, the higher order linear differential equations with constant coefficients, the same type, the equation is Euler-Cauchy equation. The only difference, the higher order linear differential equation, we are having the constant coefficients. In this equation, Euler-Cauchy equation, variable coefficients. By making the substitution, that is x is equal to e power z and log x is equal to z in the RHS of the given differential equation, and LHS side, x square into d square divided by dx square is equal to theta square minus theta into y, and x into dy divided by dx is equal to theta y. These are the substitution we are making to convert the variable coefficient into the constant coefficients. We are converting first the variable coefficient is equivalent to the constant coefficient. Then we are operating as per our higher order linear differential equation. Then we are identifying the solution to the equation. In the final solution, again we are changing the equations with constant coefficient to the variable coefficient by, again we are reversing the substitution, that is instead of log x is equal to z, we are again substituting z is equal to log x and e power z is equal to x. Okay, so these are the explanations about the Euler-Cauchy equation. Okay, thank you so much. Thank you so much for the listening. Thank you, listeners. Thank you.